I'm Andres.
I'm Edu.
I'm Andres.
I'm so.
Suspension bridges have been used to help people cross large bodies of water instead of having to travel on a boat. The suspension bridges is a normal bridge, but with large cables connecting from the top to the bottom. This is to help sustain the bridges easier and for it to be able to support large quantities of weight. The reason why suspension bridges are used in many places in the world right now is because of one reason, which is to help people export and import things from cities that are surrounded by large bodies of water. A good example would be the Golden Gate Bridge in San Francisco, which its length is 9,150 feet from one side to the other. Its cables are about 1.2 miles long, and it has a total weight of 887,000 tons. Every day, people around the world pass through that. Trucks also have to go in or go out to deliver packages and retrieve supplies. Without these bridges, no one would have a way to get inside or outside of the city, unless they use boats, which would be a major hassle.
Suspension bridges, like the Golden Gate Bridge or Brooklyn Bridge, suspend the roadway cables, ropes, or chains from two tall towers. These towers support the majority of the weight as compression pushes down on the suspension bridge's deck and then travels up these cables, ropes, or chains to transfer compression to the towers. The towers then dissipate the compression directly into the earth. How are suspension bridges and math relatable? If you take a look on many suspension bridges, they all have these cables that run from up to down in the shape of a U. This U can also be a parabola. A parabola is a symmetrical open plane curve formed by the intersection of a cone with a plane parallel to its side. The path of a projectile under the influence of gravity ideally follows a curve of this shape. The cables or chains that the suspension bridges have are all shaped like parabolas because it can withstand the tension and force that things on top of the bridge put their weight on.
Okay, this is our mathematical model. The dimensions of the actual bridge, if it were going to be real, is 100 meters from one side of the Santa Catarina River to the other. But on the model, it's 35 centimeters. This is 35 centimeters, and if the bridge was real, the two towers on each side, one on each side of the river, would be 8.29 meters tall. But on this model, they were 2.901 centimeters, but we rounded it up to 3. If the bridge were real, a vertical cable would be placed every 1.82 meters, and like I said, our ratio that we used to calculate all these measurements was 285.7 centimeters to every 1 centimeter. And to find that for each of the measurements, you just apply the ratio to it. You need to make sure that they are both when the measurements are in meters, that you have to make sure that it's in meters. So the actual equation for our line is the f of x equals negative 4x 10 to the negative 4x squared, and that is our bridge.
Once again, we see that suspension bridges are a major help to everyone, which is why they are placed all around the world. So the way we have helped to get across from one place to another. These bridges are specifically shaped to withstand forces that objects on the bridge give, which coincidentally are shaped like parabolas. These bridges will always be a help to everyone for as long as we have to get across from one place to another.
So you should build our bridge because it can carry cars and people can walk on it, and it helps people get from one side of the river to the other, and it can keep them safer if they want to prevent them from going across the riverbed. Thank you.